Great. So the lambda operator basically is essentially a way of defining a function, right? Instead of saying def f, we can actually define a function like this. So f, just like normal variables in Python, that was the biggest difference which I found from normal languages in and Python, at least the function languages. The function is nothing but like a variable. Okay, function is like a variable, and here f is a function, right, to which we are assigning a newly created function, right? Using lambda, we define an anonymous function and we assign that anonymous function to here to f, right? And just like normal variables, we can also pass function as argument to another function. Okay, so this is easy way to understand lambda. Is it clear, the first line? So we are saying f equals, we are defining a function here. This is the way we define a function. Uh, I mean, in the lambda way. So here, lambda keyword provides us the capability to create an anonymous function. So here we are. Okay, this is the way. So you can see we are able to call this with these two arguments. So you can see, so when we are calling it f with 1 and 1, we are getting the 1 plus 1, right? Similarly, we can call it with 2 and 4, right? Now, there are many functions, inbuilt functions, and these are called like generally the higher order functions that allow you to do a lot of things, such as the where clause in SQL. Similarly, we have a function in Python called filter. Now this filter function takes two arguments. Okay, one, a qualifying function from you, and second, a list from you, right? So we defined a list here. Foo is equals to 218, 9 to 22, and so on. This is a list, right? And we are saying that we are using a filter function. What filter function does is filter function takes a function from you. This is a lambda function, right? So lambda function is nothing but another function, right? Another function, okay? Just that we are not giving it a name, right? In case of lambda, we basically take arguments like this and return a value like this. Now you can easily guess that in case the function is complex and bigger, lambda may not make so much sense. If you have multiple expressions, okay, and so on, right? Okay, so basically lambda is nothing but a way to create anonymous function. So here we are saying that here we're creating a function called function like this. We are saying that if x is divisible by 3, right? We are saying x percent is 3. That means remainder, when x divided by 3, the remainder should be 0. So here we are saying that run this function against every element of foo. That's what the filter does. And this function, whatever function we are passing, also note that we don't really need to pass the lambda function. We can pass any other function. So there are these functions like map, filter, and so on. These are advanced, right? You can say second order function in which can take another function as argument. As I showed you yesterday, that we can also define our own such functions which take another functions as argument, right? Okay, so here this filter is a cool function here. Okay, we can also create one such function easily. Okay, should I show you? And let's say I'm defining my, okay, first of all, let me just explain to you what it means by filter. Now, when we run filter, it returns us another list. Okay, this list, if you see, this list is basically taking this function applying on every element of this list, and returning a new list, right? So it's not a big deal to create such a function like filter, right? I think this, let me just show you. I'm defining my filter function, which takes a function as argument, right? This is, let's say, I'm just putting underscore because we have defined f above, or let me just say func, okay? And this is the list, right? So if I have to do the same thing, what this inbuilt function of Python is doing, all we need to do is take one argument as function. The name could be anything, right? So in Python, the variable name or the function name is basically same, right? Which means that you cannot define a function with the same name as the variable, right? It'll override. Like the way we have defined f here, if we say f equals to true, then it'll basically, this function will no longer be there. This function will be replaced by by 2. Okay. Now let's try to understand this filter function by the way of defining our own function called myFilter. MyFilter, what's going to do is going to take this function, check on every element of this list, and then return the new list. Okay, so I'm going to say new list equals empty array, right? And then I'm going to say for for e in the list, right? I'm going to say for e in the list, if if function on e is returning true, right? Then we add to the list, right? Then we add to the list, okay? And what are the functions available, right? All right, so there is a function called append, okay? And we are appending it to the list. That's all. And in the end, we are returning the new list, right? So now let's take a look at whether it's working or not. So, and here we could give in the anonymous function, right? We could give in the anonymous function, and then we are saying, give me pass the second argument also. So now here, please pay attention here. Now I can define another function similar to this lambda. I can actually write this as a normal function also, if that is bothering you. I'm defining another function called is divisible is divisible by 3, right? So I'm saying is divisible by 3 if there is an x element. We basically return if x percentage 3 equals 0, we return true, else else, okay, help me out. All right, return false. So this function that you see here is equivalent of this, okay? Or I could also further make it really brief, remove all of this and say return this, correct? This is also the same thing. So when x is divisible by 3, this will return 0, this will result in 0, and then it'll be true. Otherwise, it'll be false, right? So I can do the same thing in a little more verbose manner, okay? So I can also use the existing function just like this. These two statements combined together are equivalent. So here we are, what we try to demonstrate is that one, whatever this filter is doing, it's not that big a magic, right? We could do the same thing. We could take another function as argument and we could execute it. You can see it's so simple to execute it. Just put round brackets on that variable name and execute it. Okay. So Python provides these wonderful functions like filter in case you want to go over a list and gather only the elements which are qualifying a particular condition. In those cases, we have a filter function which will basically uh, take condition or a filter function from you in the form of lambda or in the form of a full-fledged function. This function must return true or false. In case it returns true, then it keeps the elements from the foo in the outcome, otherwise it ignores them. So here, this is a very quick way of doing things. It's a really good way to avoid the for loop, right? One more thing that to keep in mind when we talk about these functions like filter and map, these functions are better because there there it's easier to express your logic, because the moment the for loop comes into play, the logic becomes complex. Okay. Second, when you have a for loop, whatever logic you create, it's strictly linear, because in for loop the you always move from left to right. But if you look at the filter function, or if you look at the filter function, it does not matter in what order are you going to apply the function on foo, whether on multiple processors, whether on multiple machines, whether from right to left, from left to right. It does not matter. As long as you are able to filter out the elements, it doesn't matter to you, right? So that's the advantage of using filter function, that when you don't bother about the when you are not worried about operating on a list in a sequential fashion, you would like to ask Python or the framework under the hood to do that traversal of the list. Why? Because let's say today you are using Python, tomorrow if you're using say Spark, let the Spark do the traversal. Maybe it's doing the things parallelly on multiple machines and so on, right? So this is the first step towards the parallel computing. Okay, it's the first step towards the parallel computing. A program with so many while loops or for loops is very hard to parallelize. Therefore, prefer prefer these kind of functions like filter, map, and so on for your general program, because that's far more easier to parallelize, because the program is generally far more simpler, right? So here we are saying that using this condition, filter the elements of foo. Now, there's a very interesting function called map. What map does is it basically translates this list into another list. Say, same size, every element of this list will be translated using this function. So here we are saying that whatever is the value, translate it into 2x plus 10, and that's what it is, right? So if foo has like 18, 9, and so on, right? So we get the we get the outcome here, right? So using NumPy, we can operate on the whole list by creating NumPy array. Similarly, using map and filter, we can apply functions on the list in usual Python, right? So this is another way of operating on a list, and it's basically easier to handle than the other parts. Now, the other thing I would like to say is that there are quite a few more tools like flatmap, right? Okay, I think it'll be flatmap or something. Okay, take a look at the other inbuilt functions. So there's a wonderful library called functools. You should take a look at the functools also. There are wonderful functions. You will use a lot of things out of functools, and like partial is one. So I think I should describe partial also, because I'll be using partial in one of the sessions. Okay, so here what you see is these are the inbuilt functions, and this makes your life really easy. Okay. One of the very useful thing is called partial. So partial is basically a way of reducing the number of arguments. Okay. So if there is a function that's requiring a lot of arguments, using functool partial, you can you can predefine those arguments, right? Let's say the f function that we had, right? In that, what you could do is you could feed in the argument. So using partial, you could basically let's say there is a particular function which is taking so many keyworded arguments from you, and every time you call it, there are let's say most of the arguments already have the hard-coded value, right? So you could wrap that function, you could define your own function, and using your function, you can call the other function. So that's the reason. So so take a look at the partial function that could be of use to you. The other thing that would be of use to you is okay. Anyway, I think I'll describe you again when we use partial this one and iter tools, right? There is another very useful library called iter tools. So one is func tools. Func tools basically for function related methods, right? And there is a library called iter tool. This is a package called iter tool. Iter tool is for efficient looping. Okay. Out of these, one of the things that you may like to do is say product and permutations. Okay. So if you want to generate a lot of permutations, like you want to product it, right? You want to like generate all permutations of 2 out of this, you could do product, or you could just generate permutations. Okay, so try the permutations and you could experiment with the permutations. All right, so here for example, we are generating the permutation of 2. Okay, so A, B, A, C, A, D, B, A, B, C, B, D, C, A, C, B, C, D, and so on. So using the permutation function, you could generate all possible ones. All right. Of course, this is to be used only in the case of larger problems. In case there's an interview problem that's asking you for permutation, you should not use it, because that's like saying that um, uh, that's basically because if somebody is asking you to do this and in an interview, they probably want you to write a recursive function to do it by yourself. All right. So when you are using it, it doesn't mean that you don't know how to do it. Make sure that you know how to do the permutations by hand, by your own program. It's completely okay to learn to do the permutations, how to generate permutations, because that is something a little harder in the programming. Okay, so if you are using a library, that does not mean that you are not supposed to be knowing what is under the hood. All right, so take a look at these functions. These functions are really powerful. Try using them, make yourself comfortable. All right, so iter tool is one, and other is these are the built-in tools. So built-in functions, not this one. I'm looking for inbuilt functions from Pythons. Yeah, these are the inbuilt functions, or you can say built-in functions. Okay, so that's iter tool, func tool, and functions. Those 3 libraries you should check out. All right, one more thing that we have not discussed so far and will be using very often when we iterate over the list. First example is that we want to generate a list of numbers, um, the square of all the numbers, right? So you can simply do that using what was that? Range, right? So you can say for I in the range, right, up to say 10. Okay, print I, right? This way you can do. Now let's say I want to put this in a list, okay, or I into I, right? So this is what I want to generate. I want to put it in a list. I want it as the outcome as a list. So I created a list. Either I can create the list or I could use this, right? Either one is completely okay. And then I say, okay, I say return dot append I, correct? And then I basically just check if I've done it correctly. So you can see this, that I have appended I. Let's say the purpose is to do the squares. Okay, so is it clear that what we just did, we basically created a list of the squares of natural numbers. Now let's say this code is little, bulky, that we have to define this, we have to do this. So there are 4 lines involved. You can do it very easily using something like this. Okay, so the same thing can be written like this. Okay, so we are saying, okay, so we are saying, um, okay, create create a list, okay, create a list using this for loop, okay, and what should be each element? This should be each element. So this is called list comprehension, right? So basically it's so quick to create a list, iterate over the things, and so on, using this kind of mechanism. So you can just put a square bracket ending with this square bracket and say I into I for I in the range, right? So which one do you like, this one or this one? The 22 or 23? Yes, great. All right, Deepak prefers 22. All right, because 23 is less more confusing. Yes, yes. So when you are new to something, you will find that more confusing. But if you see this kind of code is so common, it's like a slang, right? So it's like a slang, and if you even if you take a look at the C programming language or any other, this kind of code is so common that the authors of C, they themselves call it slang. Okay, so that basically that's why there was a need of making a simpler notation. Once you get used to it, once you start using it, you'll become more comfortable. Yes, that's correct, Deepak. So just experiment with it, try it multiple times, make yourself with it, because this you'll find a lot. You'll find it doing a lot, right? You'll find that you will be operating on this very often, right? And let me just see if I could do the same thing, right? Let's say I want to square all the values. So can I just say lambda x and x into x? I see. I just have to convert it into list. Yes. So this is another way of operating on a squaring all the values of a list, right? The map. This is another way of iterating over a list. Okay. So if I have to do the same thing, I'll prefer the map way than this one. Okay. And but map with the only problem is that it's one-on-one, one-to-one mapping, that each element of this list is being operated on by this function. So this is one-on-one mapping, and this one-on-one mapping is basically not cannot solve all kinds of problems. Say you are trying to do something in which the previous value is retained. That kind of thing you cannot do using map. Okay. Okay. So map is essentially taking the value of a list and translating it into something else. Okay. So let me just show you what it means. So what's happening here is, right, let me just draw something so that you can get an idea. That's right, Deepak. So actually the idea of map comes from here, just that, yeah, right? Okay, so I'll just show you what it means. Okay, All right, so let's just show you. This is a very important part in the computing that there are so many ways of doing the same thing. Just get yourself comfortable and know what to be used when. Okay, and okay, so what's happening is each the function that you are passing is basically translating one element into another, right? That's all, right? So how many calls are happening in this case of this function? 10 calls, correct. So there are 10 calls and 10 calls and every function call is basically taking this as argument and returning this as value. It's taking this as argument, returning this as value. Taking this as argument and returning this as value. So that's what is happening in here, right? It's not lazy, but it's just instant. Okay, unlike a Spark and the TensorFlow we'll talk about, and it's basically instant. It doesn't wait for us to give the orders, to finalize the orders. It basically does it instantaneously. Okay. So basically here what we have is we are doing the mapping now. Whether this framework of map is doing it from this side, or it's basically splitting it into 10 parts and doing it on 10 different machines, it is none of our concern. As long as we are getting our output, we are okay, right? But if we are using a for loop, then it is guaranteed that the values the values that you're going to operate on are basically from left to right, right? Very good question, Deepak. Yes, very good question. Question is, since we are operating on one element at a time, does it also help us manage RAM size? Yes, practically it can. We can implement a map which operate on like partially on the disk. Okay, so that's another advantage of this. So since we are operating on one element at a time and order doesn't matter, therefore it's really simple, right? It's really what do you say? It's really powerful. Okay. So now you know how to operate on the list and when to use what. Okay, so we talked about built-in functions. Just go over the list. Make yourself comfortable with reading the documentation. Okay, this is the best advice I got in my career. Um, that always read the manual, get used to the language, and you will find that most of the manuals are written by the author of that library themselves. Therefore, you get to know exact words, and you also get the perspective of what they want to express. So ensure that you know the go through the documentation,